Come on. Here we are. We're going to do some microbit fun. I'm excited. I love microbit sensor stuff. There's so many cool things you can do.
So many things. I know. It's fun. Let's see how much can we do? Where do we get? So
Yeah,
ready to get started whenever you are.
rock and roll. We're here for another Logix co-taught lesson. Microbit sensors. If you haven't done stuff with microbits and you're doing coding, it's great to do Scratch. It's great to do robotics and Blockly and all these other things. But it's also wonderful to have something in your hand that is doing something. Rock, paper, scissors, measuring temperature, doing all these fun things. So that's one reason why I love microbits. Herman is the ninja who's going to be guiding us today with all his knowledge about microbits. And we both love doing this with students. And we're here on behalf of Logix Academy and Digital Moment. And I'm here on Treaty 6 territory in Alberta. And we're going to get started because we're a little behind. So this is brought to you by Digital Moment. And I'm ready for you to share your screen and for me to stop talking and for us to get rocking and rolling.
Perfect. So let's do that. Let me share the
Yeah.
screen. We start with this ugly, empty screen, but that's the way I like it. That's the way
All
we
right.
like it. That's the way we start with
Ugly
something
up.
empty. What we're going to do today is we're going to continue talking about microbits. But now we're going to have the microbit and we're going to experiment and experience what can this device sense of the environment that is around it. Last time we worked on the emulator and we did many things. We're going to try and recap a little bit of what we did so you don't feel like you're panicking. And we're going to cover a bunch of things today. Feel free to pause and rewind. If you're here with us, ask me questions. Let's try to figure out what can we do, what can we learn together. So this is going to be fun. Thank you so much, Logix, for having me here, and for Darren for being such a great host. And we're going to get started. The first thing that we did last time is going to be the first thing we do today. I don't remember the URL. What's an URL? What is that name? It has too many letters, too many things. So we just search. Can I search for make code? Mine already bring me things, but I'm just going to go to make code, and we're going to click on the one that has the nice circle with the face. That's a nice face, a small face. We go there, and same thing as last time, I'm not signing in. By now, it's maybe good for you to start thinking about creating an account because maybe you want to access your projects from different computers. You can save your project on your computer and maybe you can download it and save it on your Google Classroom. But this way, they're being hosted there. And regardless if you're at a friend's house or at school or at your house, then you can open your projects. But today, we're going to go and create Fluffykins 2. Let's go with Fluffykins 2. We're making our second Fluffykins. And once again, it says the tour. We're going to skip the tour. And what we saw last time is that we skip lots of things because it's not that important. We were focusing on what we really care. And what we really care was this area. This is our virtual microbit that today we're going to be experimenting with our real microbit, but we know that this virtual microbit helps us create and project and make mistakes, lots of mistakes, very important mistakes in order to learn and to practice and to experiment. This is great. The second part, we saw that we have a bunch of blocks and we use the search bar because that way we don't need to remember specific blocks or where do they live. We just remember fuzzy words, keywords that can get us there. But we also saw that when we click on one of the blocks, then these are blue blocks and gives us a list of things that we can try. We experimented, we show numbers, we show text, we turn lights on, we turn lights off. And then this is our working area. This is my desk, and we had done start and forever. And we experimented with interesting things. We said that on start, it just starts as soon as the microbit gets electricity, does something once, and stops. What else do you want me to do now? The forever, it just keeps going. It's forever is for as long as the microbit has electricity, it's going to keep repeating, it's going to keep looping, it's going to keep processing all the instructions we gave it.
That's one thing I learned last time. I didn't realize that where you put the forever block is the order in which it does that forever loop.
Which is so interesting, isn't it? It's
Yeah.
one of those things that it's hard to consider when you're talking about blocks, because on text base it's very easy to see
Yeah.
because then
Yeah.
it's
Yeah. Yeah.
slowing down. But here the order is a little bit fuzzy. Let's call it fuzzy. But yeah, we try things, and most of these things, I want to invite you to think about this. Where do we, Darren and I, learn these things? Some of them with lessons like this, the fundamentals. Some
Mhm.
of them with tutorials. Most of them by making so many mistakes and just trying things out.
Yeah. Or a student saying, this isn't working, or this is working, or look what I did, or yeah.
Yes, yes. One of the things that I like the most when I'm coding with students is that I have an idea of what I want to do. I have a set of blocks that I have in mind, but then a student comes and throws something completely different. And then we're in uncharted territory, and we can have two different outcomes. Usually, it just fails miserably. 5 steps from now, we learn from that. And you know what? We just go back and erase and nothing happened. Or we find a new way to do things. And this is really exciting because then we don't hold the truth. The truth is something for us to explore within the platform.
Yeah.
Now, I'm going to get rid of this because what I want to do to start is to recreate the application that we ended with, because
Okay.
we're going to start with that. So we refresh our mind. There's a lot of things. Maybe you're tired today. Maybe you didn't see the last lesson. So let's go back. And what we were saying is that our microbit has buttons. And those buttons are things that the microbit receives as input, information we provide, messages, actions that we give to the microbit so it can start working. In this case, I'm here in input, and last time we selected button A. Let me make this a little bit bigger so
Boom.
we can see it better. That means when we press the button A on the microbit, something is going to happen. And what we did is we said we're going to recreate a coin toss. So is it going to fall on heads and tails? I'm going to code it as we did before. We said we need to have the computer to choose a random number between 1 and 2. And we said that was on math. So we're going to go and say, okay, computer, pick a random number between 1 and 2. And then we ask a question. Is the number 1? Yes, show heads. Is the number 2? Show tails. And we did that with logic, providing what we mentioned, like a decision tree, like different options that lets us take different paths and go to different places. And we go to logic and we pick this one. And this one, we also saw that with the plus, we can expand or contract to add many different conditions. We're going to start with the same project we did. And we said that this pick random cannot fit here because a hexagon and a rounded rectangle, they don't match. We need a hexagon inside a hexagon. That means that this true is a question. We're asking a question. If whatever we're asking here happens to be true, do something. That we cover with logic, and with logic, we say hexagon in hexagon. I'm going to move this so we have lots of space. I'm going fast over this part because this is just remembering. So we say when we press the button A, we ask a question. The question is pick a random number between 1 and 2. 1. Is that number equal to 1? If the answer is yes, do whatever is here. And we said, show me a happy face. We know that in BASIC, we had the show icon and we selected a happy face. If the number is not 1, there's only one option left, 2. So if I expand, that means that if it's not 1, else, meaning otherwise, show me a sad face. So this is the
Right.
part where I'm here. I'm going to pause here for a second. Maybe you're copying it again. Maybe you want to think over the code. I'm going to read it once more, and I'm going to wait a few seconds. Our code
Yeah.
is trying to replicate a coin toss. The way we trigger that towing cost is by pressing the button A. As soon as the button A is pressed, all the instructions contained within that block start being evaluated and executed. Everything starts happening. The first thing is that we ask a question. We're saying, if something happens, show me a happy face. If that doesn't happen, then show me a sad face, which we use to emulate heads and tails. It can be anything you want. What is the question we ask? That question is, computer, please pick a random number between 1 and 2. And if that number is 1, then do this. Otherwise, meaning it's not 1, so it is 2, do this.
Yeah. And you could, if you wanted to, expand that and say, specifically, if it's a 2, do this.
Yes,
Like,
let's do
that's
that.
the other way to do it. Not that, maybe don't trust it. Maybe you're like, Ellis, are you sure? Just to see, well, is that really what's happening? I don't know.
It's a great idea. What we're doing here is terse, seems kind of nice and concise, but what you're saying is very important because, as we mentioned before, you're the one that is building your code, and you build it in a way that makes sense for you. And
Yeah.
what Darren is saying is that there's a way for us to be very explicit. Right here, we're letting the computer imply things. And that usually leads to trouble. Usually, there's something that is going to happen. The computer is going to, I think you meant this. No, I don't want you to think. Just do what I want. So look what happens. Now we have an else if. So if it's not 1, then we ask a question again. We're going to have an issue here, a big issue here. It's okay. We're going to face the issue. We're going to skip the solution to the issue. I want to see if you can figure out the issue. Let me copy the code. And we're going to say, if the pick random from 1 to 2 is equal to 2, show sad face. So first issue, you're saying, what are we going to do with this space? We have an extra else. Can it be an else? We have only 1 or 2. It can never happen, but as Darren said, we need to close this loop. We cannot leave things that are ambiguous for some other coder to understand, and especially for the computer to misinterpret or misunderstand. We can solve this issue by clicking on the minus. I don't want this last step.
There you go.
But we have a huge issue here. I'm going to give you 10 seconds. Take a look at the code, try to read the code, and imagine what's wrong with this code. What is happening? We're doing something that seems okay and very clever, but it has a big issue. I'm sure some of you are already finding it. Let me read the code for you. We're saying, when we press the button A, the first thing we do is we ask a question. Computer, pick a random number. 1. Perfect. Then it goes and shows the happy face. It's working great. Not a problem. Let's try it again. We press the button A. Computer, pick a random number. 2. Oh, so it's not 1. So it goes and it picks a random number. What if it picks 1? Oh, we broke the program. We need a place to save that information. Those are called variables. We might do that at the end. But for now, we're going to skip those variable parts. We know that we found an issue, and it's important. It's a good way, sorry, for us to think about this. But I don't want to go into variables yet because I want to focus on sensors. We might get to variables after. What do you think, Darren?
Yeah, maybe. So, and if you're thinking, I don't like how that code is, maybe I'll just keep it with the else. Maybe I'll go back to that. But just seeing the logic, that's what I love, is just being able to read through and find the logic, find the errors and testing it out. That's the best part.
As you said, is to read it. And especially, you saw something that we did here when we were reading it. I didn't even test it in the emulator. We're reading our code and we're anticipating different scenarios. That's super important. For now, I like Darren's idea. You're a smart man. Let's take this out. Let's take this out. So we bring it back and we leave the else. We know this has no issues. If we test it, we know this is going to be working. So far, why am I pressing B? Let's press A. This is a happy day. There, we have a sad face. That's fine. We polished last time. We added sounds. We cleared the screen, many different things. But now I'm going to take all these and to say bye-bye, birdie. So we're going to get rid of that content. And what we're going to talk is about the microbit itself. We know it has the buttons, it has the screen, it has this golden strip at the bottom, which is maybe for another day. We can connect it to many different things,
Oh, yeah.
which is really cool. Sensors, light sensors, temperature sensors that are outside of what the microbit has, motion sensors, humidity. There's so much, but we're going to focus on what the microbit can sense just as is. And we're going to start with a simple example of one of the sensors that can make the microbit lots of fun.
Cool.
Let me show you something. We have, so far, I'm going to start bringing buttons and, blocks we used before. I have a pick random. I'm going to say from 1 to 6. So I'm changing the random number. I'm going to say basic, show a number. And what I'm going to do on button A. Where is the sensor there? Herman, you're lying to me. It's okay. We're going to get there. What I want to show you is that with this, look what I'm creating. When I press the button A, I'm going to display a number on the microbit that goes from 1 to 6. What can this be? What did we create here? Start trying to think, what can this program replicate? We're doing 1 to 6. You could also express it maybe 1 to 12. That's another option, but let's put it 1 to 6. If any of you is thinking or saying, oh, dice, yes. So we're making something useful. We press the button, we get a random number every time. And then this can replace dice. And 1 to 12, then we have 2. But what I like about this the most is that I want you to think about this. When you have a physical die, that has physical constraints. So if it has 6 sides, that's it. But here, I like to do this, -5 to 9. And I want you to think the repercussions of doing something like this with a game that I don't like, but that I'm sure you've played. It's Monopoly. What happens if you're playing Monopoly and you roll -5? And then you need to cross at the start line. Do you charge when you go backwards or do you pay? How is that going to change the game? You're changing the rules because now you created a device that enables that. That's the beauty of code, is that your imagination can start changing rules and making things different.
That's a different Monopoly. That's great.
I know it's still going to be awful, but it might be different.
Oh, Monopoly's the worst. Never mind.
I know.
Yeah.
Good.
Okay.
A lie in our hate for Monopoly. I apologize with everybody that loves Monopoly. It's good for you. Okay. So now we have button A, but one of the things the microbit can sense is movement. The same way that phones can detect if you are on landscape or portrait mode, the microbit has an accelerometer, something that detects if somebody is moving it, how fast, in what direction. And we can take out this button A and enable that movement by going to input and selecting on shake. So now, instead of pressing a button, it feels like we're just throwing dice because we're shaking the microbit. The next thing, before we download it, I want to show you that the emulator accommodates for this type of concepts. We have 2 things. One is now when I move my mouse over the microbit, it kind of moves, it's shaking. But also I can click on this virtual shake button. So really important, very useful, a fun way to play and to interact with the device. But we'll see that that shake, that acceleration has lots of different applications, and we're going to play with a few of them today. But as I said,
Love it.
yes, Darren.
No, I love that. I love the emulator, how it shakes too, how it moves as if
I know
Yeah.
it's just that sometimes it's hard to get it to change.
Yeah.
Sometimes you really need to go very fast.
And if you shake your microbit next to your ear, you can actually hear the moving parts for the accelerometer, right?
we hear something, I always doubt if that's the movement for the accelerometer.
Yeah. What do you think it is?
Uh, I think is something else. Is a connector. I think in this button or here. I don't know, but that's a good thing. And this brings me to something really important. What Darren and I are doing is now we're nerding out in a really fun way. What is this making move? But I love the idea of nerding out. And what I want all of you that are watching this to go on input, select acceleration, and in this block, on any block, but on this one, you can right click and click on help. When you click on help, if you scroll down, there's something that is very exciting. There's this gentleman that shows how the accelerometer works with Legos and gives a really good explanation. I invite you to watch it. It's a fun watch, but also it's an interesting way for you to learn about what is this acceleration? What is peak random? How does it look in JavaScript? How does it blah, 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 blah? So many different things. Okay, we got sidetracked. Thank you so much. I love being sidetracked and finding different ways. It's the best. So we want to bring this to our microbit. How do we bring it to the microbit? The process is very simple, but it's with everything. Sometimes it fails. I'm crossing my fingers, hoping that it fails today, because when it fails, we learn and I get to troubleshoot things with you. There are two ways to get the material from the computer to the microbit. We're going to explore one that is very simple, that you once set it up, your microbit and your computer know each other and they understand each other. So what do? The first thing is that we have this big purple download button at the bottom. We click on that, and then we're going to have a series of screens that are going to guide us. It says, connect your microbit to your computer. So I have a long USB cable. You should have maybe a white or a black small USB cable, but I want to show this to you. So I plug it at the back. If you have a V1 like mine, so that is flat, then you would gonna have an orange light blinking saying, oh, I have electricity, I'm here. By the way, this is very silly, but I love silly questions and answers, is that you plug the cable to the microbit, but the cable is plugged to the computer. So step number one, set. That was easy. Then we say, let's go to next. And it says, great, you connected, but now you're going to introduce the microbit to the computer and the computer to the microbit. They're going to be paired. They're going to know about each other, and then they can communicate. The other way, we did downloading the file, but we're going to go with this one, and hopefully it works today. So I'm going to click pair. This is the different screen. As you can see in the little video or animation on the screen, this one is white, and the connect is on the left, the cancel is on the right. On mine, the cancel is on the left, the connect is on the right, and it's dark. That depends on what operating system you're using and the settings that you have. But yes.
What's your advice if you don't see the microbit in this window? Like it's not showing up for students?
That's a great question. The first rule of Fight Club, of computers is unplug and plug back again.
Yeah.
And that usually just takes care of things. And that when that doesn't work, I'm gonna tell you the extreme thing, you close your program and you open it again. And usually that solves everything. but most of the time, as Darren was saying, we unplug and plug back in. And then what should happen is that you will see in this window something that says BBC microbit. And that means, oh, I have something that is a microbit. Do you want to connect it to the computer? So I cannot click on connect right now because it's grayed out. To enable it, I click where it says BBC microbit and my connect button comes back to life. We click connect and let's see, do I pray? Do I hope that this is going to fail? Sometimes it's better because then we can debug, but let's try. I connect, it's connecting. No, everything really well. We have happy microbits, we have rainbows, we have everything. The beautiful thing is that you do this, and now all I need to do is click on download. Let me bring my microbit to my screen. And what you will see is that the light at the back of the microbit is blinking. That means we're having a communication between the computer and the device. So that is being sent. Now I have the number 5. I shake and we have the number 2, and we shake, we have the number 5. So we created our dice. Imagine if we take this and we put a battery pack, then we can play our game. We can play our Monopoly game with -5 to 9 or -5 to 45. You try and see. It's going to be a lot of counting, but it's going to be interesting. So
Awesome.
that is one of the ways, the shaking that detects acceleration. Sorry, Darren, were you going to say something?
No, I love that. Do you ever do other things in that shake, or what other sensors are you thinking about?
I want to show and play a little bit with light and acceleration, and I want to show temperature. We're not going to play with that, but yes, there are many things to reveal. But I don't know if maybe you meant us clicking on the shake down.
Well, I just know every student is going to click on that. Well, not everyone, but a lot of them will click and just see. So you can just see that there's a logo up. So maybe you just want, instead of shaking, you just want to go, whoop, turn it up or down or tilt to the side. Free
Many
fall.
different things, yes.
Have you done free fall?
Free fall is the one that I recommend for the sanity of your device. Your classmates, maybe not. There's a free fall activity that is really cool, is that there's a way to extract data. So what in your school they do, maybe with the egg drop, you can do it with a microbit, and then you get real data of how fast it's falling, how long does it fall for, many different things. So
Cool.
Teachers, that's a cool activity. You can bring your egg drop to a microbit drop. And I had one teacher once saying, but isn't that going to break the microbit? My answer was a little bit snarky, but in good terms. I said, I hope you protect the microbit as well as you're trying to protect the egg. So in that case, you're good.
Cool.
Yeah.
Lots of potential.
Many, many different things. So we have this idea. Let's take a peek and see what other sensors we have. We're going to explore a few, and then we're going to do an activity considering a different set of skills and concepts in order to apply sensors.
Ooh.
What sensors we have? If I go to input and I start scrolling down, we have acceleration. So acceleration on X, mg, milligrams. What do we do to know what mg is? We can hover over the block, and it doesn't say, but I can right click and it's going to tell us that it's milli-Gs. So 1,000 of a G. Like when you see on a roller coaster that you're going really fast and you're going 2 Gs, then this is something you could measure with your microbit. You can have a class trip to Canada Wonderland or any other amusement park and track different Gs. That would be really interesting. And we can track them on different axes, X, Y, Z, or just how strong it is. As you saw in the shake, it has, is it a 1G or 2Gs or 3Gs? That's a really cool one. We're going to play with that eventually. But for now, I just want us to see, if I put show number, let's put it in forever. So we see this changing. I have forever, and it's showing the acceleration on the X-axis. This, it's a little abstract to see, because now I see the AX here and we see some numbers show up. So it's an interesting one that we're going to apply later on. There are other ways for us to see graphs, but that's a little bit out of the scope of today. But as you can see, the emulator tries to provide some help so we know what's happening. What are we doing? Let's see what else we have. So that's acceleration. If we keep on scrolling, light level. This is really cool because with light level, now take a pick. This one gives us this little sun that we can make really bright at 255 or really dark at 0, and is how much light is the microbit receiving. There's a catch with this. We're going to go into the catch shortly, but one of the interesting ideas is that maybe you can create a heat map or a light map of your classroom. If you go to every area of your classroom and maybe on button A, you show the light level, you track it, and then you can draw that for your classroom. How bright is Johnny's desk versus Lily's desk? How or how hot? How hot, you say? Yes, because we can also have temperature. I told you there was an issue with light. We're going to get there. We can have temperature. And temperature, we get the equivalent of a thermometer. And it's going to give us the temperature of the device and the environment around it. So these are really cool. The issue and the magic of the light level is that the light level is measured with the LEDs themselves. The LEDs produce light, but there's a way for them to sense light. The issue is that if I'm displaying something, I'm distorting the information because I'm producing and part of that light is being filtered in.
Oh.
A little bit tricky, but there are practical things we can do.
What I like is if you're ever thinking as a teacher, like, how could I use this? One of our outcomes in science is the needs of plants and animals and how they respond to stimuli. And you're like, oh, look, there's light and there's sound and there's all these different things. Temperature.
Yeah, I really like that. There's a project that is on my back burner to do, and I made a few pieces, but is thinking about exactly what you said, Darren, is to have a microbit that is detecting light, and then we have it tracking packets of light, and that can be an emulation of a leaf, and then it's tracking light, and after a few moments it captures a certain number of light and then sends it to another microbit that can be the trunk, and then that transports the information to the root.
Oh,
So
cool.
you can create a full system with other cool things that we're going to see a little bit today.
Oh, wow. That's a neat idea. You could have a bunch of leaves.
Yes. Yes.
Oh, cool.
Yeah. So many different ideas, light level. To that extent, we also have we have the temperature, we have compass heading, so it can be used as a compass, or it can be used to detect the magnetic field. It can be the one of the Earth, or just a magnet. And with the magnet, I made a project that was lots of fun. I had several magnets on a table that were representing flowers, and the microbit was a bee. So we had the microbit go from flower to flower, and it sat and it will show that it's filling up. And then the idea was not only to code it, but to figure out what is the average amount of nectar and pollen that a bee captures per flower, and then to have that result at the end so we can emulate many different things. So this is really cool. We have many things. And if you happen to have a version 2 microbit, it can also detect the sound level. So if it's really loud, it's gonna say ah. If it's not that loud, it's gonna say ah, something like that. Great. I just gave
Cool.
another 2 screenshots for Logix to put in my presentation. Good.
Love it.
So we have, let me see, how are we with time? Yeah, we have about 20 minutes. So
Yeah.
we're going to explore one activity that uses these sensors. But I want to think about the activity and the sensors in a practical way. How can we use this? And how can we refactor? How can we improve? How can we prototype something and make it a little bit better over time? What is my goal? My goal is that today I'm in my home office, but when I'm not in my home office, I have one or two of my coworkers are stealing my food from my backpack, sort of taking my backpack. I want to protect my backpack. How can I do that? many ideas because we don't have that much time. We won't ideate too much about each one of them, but I want to use different sensors that we have here to try and create an alarm system. You can ideate some other that we're not going to use. We're not going to use the magnetic force, the sound level, or the temperature. I'm going to focus on these two today. Homework. I'm giving you homework. Yes, I'm giving you homework. Your homework is to ideate how to use maybe the magnetic force to create a different thing. Let's think about this. My backpack, I want my microbit to tell me if somebody took my backpack, and I want to use the light level. Okay, if forever show light number, so what I can do is, what if I put the microbit and I cover the microbit, I put the backpack on top? That means that it will be really dark. So if it's really dark, we're okay. But if somebody takes the backpack, it's going to be bright, then I get my alarm. Okay, let's try to code that. It follows the same ideas. We're asking a question. If it's dark, just chill. If it's bright, then just let me know that somebody's stealing my backpack. I want to protect my sandwich at all costs. Great. So we can leave this concept of forever. Our microbit is protecting my backpack all the time. I don't want to show a number. I want to ask a question.
Sometimes in our mind, I find if you put that back into the forever loop for a second,
Yeah.
the emulator gives us some helpful things too, because there's some numbers that don't make sense necessarily. Like the
Oh,
128, like what's the maximum number? Like what is bright to a microbit? And if you go to the emulator and drag that light down, you're like, oh, that's bright.
that is such a
That's
good.
bright.
I'm so happy you mentioned that for different reasons. The
Yeah.
first one is that yes, the emulator here is to help us test and understand. There's also is going to invite you to do further testing because maybe I said, you know what, zero. If I put the backpack on top, it's going to be zero. Is it really going to be zero? Is there a little bit of light peeking in? How can we test that? The other thing about what Darren is saying that is really important is what is 0 and 255? Are these lumens? Are these watts? What are we measuring? If you find out, it's just a range. It's a range from 0 to 255, and then one represents really bright or really dark, but it's not lumens or any traditional light measuring system.
Oh, right.
Great. Thank you so much for bringing that up. Really important. Let's ask our question. If it's bright, showing that if the light level is, oh no, if it's dark, let's try and do it both ways. I always get confused. I love getting confused. So we're going to say, I'm going to bring the equal. If the level is equal to 0, then everything is protected. But we just had a conversation. If I put the backpack on top of the microbit, there might be a little bit of light peeking in. So I might need to figure out, I might need to experiment. So the equal seems very restrictive. What we say that if it's less than, let's say, 10, I don't know if this is going to work. We're going to have to test it practically. And then if this is the case, we want to show nothing. We don't want anything. We want peace and harmony. Nobody's stealing anything. Then we are good. Let me delete all this so we don't have so much noise on my desk. We can bring them up after. Now, if it's 10 or more, I'm going to start with a terrible naive approach. I'm going to show an icon that shows this shows like this is like a body. Yeah, that we have someone. Then so let's download, let's think, and let's see if this works. So I'm downloading. As you can see, I just press download and presto, I have, and then we have a body showing up. So that means that it's working. I'm gonna cover it, and oh boy, how do I test if it's showing nothing? I don't see. And then what if I pick a little bit? Oh, I'm picking a little bit and it's not being triggered. So maybe I need to adjust my numbers. But the biggest issue is that somebody took my backpack. There's going to be a light, or I'm just giving them is a reason to laugh at me because they're going to see my microbit showing a body there and say, oh, great, I have that. Or maybe they know a little bit about Indiana Jones. They cover the backpack with a blanket or a jacket and then take it out, and the microbit never gets light. That's
Mhm.
a clever approach. So that means we're onto something, but maybe the light level is not the best idea. And the jacket proves to be a problem. Okay, so back to the drawing board. We know that the light has that issue that somebody can cover and fool. And second, we don't want just to show an image. We want to know what's happening. So leave the forever. Let's take out the question and let's leave this and that. If we don't use light level, maybe what we want to do is to have the microbit inside the backpack. That way it's protected. Then they cannot fool it in any way, and we can detect motion. That's going to be interesting. So we're going to ask our question. In our question, we can say that if the acceleration, now we go to acceleration, and this makes us think, do I care if they move it on the x-axis, the y, the z, or the strength? That's a hard question because the axis is going to depend on how we position the microbit within the backpack. That leads me to think that we shouldn't consider axis. Maybe just the strength. Is the acceleration greater than the normal acceleration the microbit is feeling? Is the microbit feeling an acceleration? What is the acceleration that we are all feeling at all times? Try to think what is the force that is accelerating us, keeping us close to the ground. So I hope you got there to gravity, and we have milli Gs. So if we is 9.8 meters per second, so it should be 980. But you're gonna have to test it and try, and you're gonna find that it's around 1100. The difference with the sensor, the microbit, and the way that it's calibrated, it doesn't give us 9,800, 980, but around 1,150. I run it to, if it's less than 1,100 milli-Gs, meaning 1.1 G, then don't tell me anything. Things are good. But if it accelerates more, then don't show me an icon because the microbit is inside the backpack. I cannot see it. I want you to take a look and see which one of these things we can use. I know, I can sense you're yelling at it. Like I see it. It's red, it's bright, it has headphones. So we go to music. And in music, we're going to explore two things. If I put this, so now I have an alarm. It really has an, oh, we have balloons. I missed the balloons. Perfect. So we have an alarm. And the alarm goes for, sorry, for 1 beat. We can make it longer. But what I want to point out is that if you happen to have a pair of headphones like the ones I have that have this type of jack, that is the little needle, and you connect them as is shown in the graph, your headphones turn into tiny speakers. Two very important things. When you do this, make sure you take the headphones out of your ears because it's pretty loud. It's not super loud to annoy the whole classroom, but it's going to be very loud for your ears. So if your teacher has access to alligator clips, this is a great way for you to experiment and connect. But
and if you're,
yeah,
well, I was going to say, you're talking about the backpack, and that's great to make a little burglar alarm. But if you're also studying the Earth and natural forces, you just created a seismograph. Like that is what it is. It measures shaking.
correct. And
Cool.
then we with the seismograph, and if you dive a little bit deeper, there's a way to see
Oh, yeah.
the wave even happening. Teachers, yeah, microbit and spreadsheets. Great. That's all I need to
Cool.
say. Perfect. Now we're getting better. But How much time do we have? We have plenty of time to be now not better, but fancy. We're going to be fancy. We don't want to make noise because we want to catch our thief in action. So, what we're going to do is different. It's exciting and it's another property that is kind of grouped within sensors, even though it is not sensing, but it's a way of communicating very particular and peculiar of the microbit. Right now, what we're doing is that forever our microbit is sensing, are we moving? Are we moving? No, we're good. We're moving. We want to say, hey, somebody's taking your sandwich. Go and get them and see what's happening. We did it with sound, they can run away, but I want to catch them in the act. So what we can do is, if somebody moves the backpack, we want to send a message from one microbit to the other microbit that I have with me because I'm somewhere else in the classroom doing different things. That means that we're going to communicate from one microbit to the other. And we do that using radio signals. The microbit can send radio signals, and that makes it really powerful and interesting. And that can help communicate not only one microbit with another, but one microbit with many. The way that the radio signals work, it's similar if you have used maybe a walkie-talkie, a way of communicating, and it works in a way like a text message works, a phone call. The first thing that we need to agree, if you're using a walkie-talkie or a text message or a phone call or an email, is where are we meeting? Where are we talking? Where are we communicating? What is the channel? What is the email address? What is the phone number that we're talking? So in this case, if we go here to radio, this radio is not for you to listen to the radio. I tried. It would be awesome, but it's not that idea. It's to communicate. The first step, we need to decide our radio group. So I'm going to bring our friend on start. When the microbit starts, we pick a radio group. And I say, Darren, I want you to be on radio group 1. That way, we can communicate with each other. Cool. And that means that maybe we say, Darren, let's be maybe in radio group 188. Nobody knows we're there, so we have a secret conversation. I want you to analyze and think how secret the conversation is. Is there a way for someone to go over all the radio groups and see where there's a conversation and intercept? So now we're talking about security. Very interesting. That's something extra that can be done. But for now, let's say we're going to be on group 0. So every microbit that is on group 0 is going to be able to be part of this communication. This is my microbit. This is the microbit that is sending the information. We're going to have one for sending, one for receiving. For simplicity today, they're going to be the same for both codes, but there are ways to experiment, and I'll share with you how can you easily experiment and create it. So we start, and this is our phone number, this is our channel, this is where we're meeting if we were in person. Then forever, we're detecting, is the backpack moving? No, we're good, good. Is it moving? We need to send a message that anybody on this radio group is going to hear. I click on radio, and we could send 3 types of messages. One is a number, the other one is a number and a concept, and the other one is a string. So yay, or thief, or burglar. In many cases, the message is not that important. We can use that message to process, but for now, I'm going to get this one that says, radio sends string and sandwich or thief. And then it's sending this message to every other microbit. Sorry. So this is the one that is in the backpack. So we need the code for the microbit that is not on the backpack, the one that I have with me. I'm going to code it here. Let's code it as individual, I'm going to assume that this is the receiver. This is the sender and this is the receiver. I'm going to do it in this, and then I'll show you an application that makes it easier. So what we need to do is we need to do also an on start, and it's going to be the same group. So this is me receiving, and in this case, when I click radio, I have also 3 ways of receiving. I can receive a number. Am I sending a number? No, a string, so not that one. I can receive a key value pair, like a dictionary. So where we have a word and information, nope, I'm not sending a key value pair. I'm sending a string. I go to radio again, and the last one says, oh, receive string. When I received string, I can play the alarm here on my microbit. That's one option. I can add an image. That's an option. I can add some text. I have different things we can do. What I'm not doing is I'm not using the word thief. Can I access the word thief? I think we can. And it's really cool because I can say basic, show string, and how do I replace hello with whatever is being sent? I have it within this red bubble. I can drag it, and then it's going to show me whatever is coming from the sender. I want you to think about what we did. One way of representing it is that both microbits have this code, and both microbits have this code. And this is a fancy alarm because now you can go and catch the person in the act and say, come on, I'll be more than happy to bring you a sandwich, but don't steal my sandwich, please. And then we solve our problem, we ideate, we create. How can we do this? We can do it 2 ways. One is that I can create Fluffykins send and Fluffykins receive. That will be 2 programs, and we download them that way. And that is really nice. And this is a simple set of code. It's short. We can take a snapshot and replicate what we need. But there's something called a multi-editor. So let me say make code multi-editor. And then it shows me multi-editor. And this multi-editor lets me code 2 projects at the same time. So I can make one that is the send, and then the other one is going to be the receive.
Oh, cool.
And that makes things much easier because I don't know you, but my memory is very short. So I need to be flipping and switching, and I forget or take images. Here I have everything and makes things super.
And you can pair to the same microbit, or do you have to pair to a different microbit? How do you?
2 different microbits. Yeah. You pair it to different microbits. This is something that, in honestly, most of us don't use that much, but it simplifies the process when we're working, especially with radio, that we need to have content for both. Oh boy.
Uh-oh, Fisherman's friend. You know, Herman, I had a student who used the radio, and they made a game of catch. So they made a game of catching emojis. So when it received a string, it showed a picture, and he was like, look, Mr. Malte, I made a game of catch. I'm like, that's actually really cool. So went on shake, send a digit, and then it was like they had an emoji going back and forth. I was like,
that is great. I love that project. That project, I presented it in a few conferences. And what I like about that project is that you can engage a 4-year-old and have them have fun and think what is happening. But also, we had engineers, professionals, that then we have a different conversation. And then the topic of cybersecurity and protection. So it's a super simple application that expands greatly. Is wonderful. Yes.
And the best part was I didn't show a student how. They did it themselves, and
that's even better. You had a really talented student.
Yeah.
And thinking about it, if they did it, they can even make it fancier after some time. Is that maybe you send random numbers for random emojis. So maybe you're playing a game of catch, and what are you capturing? Are you capturing the ghost or the skeleton or the dog, and then maybe a counter? I get excited when I hear these things. It's fun. That's all I have for you today. Uh, I hope you enjoy the idea and the concept of sensors. I know there's a lot of information, but you can pause, replay, repeat, and reach out. All with art. You can reach out and we can support you in
Yeah.
your journey. Microbits are fun. Microbits most likely are in your school. Somewhere in your school, somebody has microbits.
Get them
Just
out of the
knock on
closet.
the door. Yeah.
Yeah. So what are the maximum and minimum numbers for the accelerometer? Is it the 1023?
The minimum is you can go lower. Let's try it out because the maximum I think I've seen up to 4 Gs, but let me see if we have something in help.
Oh, okay, I see.
But if not, we're gonna try something second in a second. Minimum, maximum. We have the formula, we have the return, minus 23 and 1023, depends on the direction if we're on X. But I'm going to take this opportunity to do something that we didn't do, which is really cool. I'm going to get rid of all these. Please, everybody, don't get confused. We're just playing and experimenting. And we're going to go into advanced. Pam, 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 pam. And we're going to get from advanced serial, and we're going to say this is acceleration, and I want to see the strength, and I want to see these forever. So we're not displaying the information on the device, but we're sending the information from the device to the computer. I'm going to download it because we could see it in the simulator, but I want to take the opportunity that we can see it on the device.
Ooh, yeah.
So if I click on the device, now, let's see. Come on, reattach, re-engage.
Okay, cool.
Then we have 3,533. I think my USB is the one that is failing me a little bit. But I think the maximum I haven't seen anything past 3,600, but maybe it's just me.
Cool. And then how still can you get? Can you get it to zero? Are you not
Yes.
moving?
Let me see. Let me see how much am I shaking, but not to zero. Why not to zero? Because gravity.
Oh, cool.
So as you can see, look, it's giving us about 1060, 1050. So that is the stillness is at that level.
And what's amazing,
really cool.
This is so cool because if you're a grade 2 teacher, you could do on, shake, show an emoji. And that's pretty cool. And then just you get a little bit more competent. Maybe you're doing junior high. I want to actually get this data. Or you can really scaffold from the simplest thing like measuring temperature to the sensor data, which is so neat.
Yeah, it's so many possibilities. As you said, it grows with your audience. It's beautiful that way.
Cool. Thanks for indulging me because I haven't done that much with the accelerometer. And hey, why not? Why not chat? Because we're both microbit fans. We do a lot.
Of course. Yeah, no, and then this is going to inspire someone to do something really cool for sure.
Yeah. And that serial, right, that could be the light. That could be
correct.
Magnet, that could be whichever of those.
There's something really cool that a project that I saw and I tried it, and is we can do light, then we duplicate this with temperature, and then let me bring this here. So we're measuring light and we're measuring temperature. And what we did is that during the solar eclipse, we had the microbit detecting, so you could see the correlation as the light goes down, the temperature goes down, and then how it goes up. So you get to chart the eclipse.
Can you download that really quick and show us some data from your device? We have 1 minute, Herman. Let's have some fun.
Yeah, let's data on device. Let me download. Let's get it down.
I mean, why not? Just you and I.
Why not? Yeah, of course. And then we're here. Remember this? Oh, this is bringing acceleration still. Okay, light and temperature. Let's try to decrease the light. Let's try to increase the light. The temperature is not varying that much.
Yeah.
But once, there, we got it a degree up. That's pretty cool. So we can pause. We can download. This is going to be an extra fast of things we can download. Let me put that on downloads. That's fine. And what we can do, we're just going off the rails, but that's fine.
Yeah, 30 seconds. Yeah.
30 seconds. I can do this in 30 seconds. Let me open, what is my, is it you? That will work. And then we go to a new spreadsheet. and we can say, I want to import the
Oh, wow.
data we
Yeah.
just downloaded. And that is a CSV, is a way that it works really well for us to communicate information between different programs. We replace, and then
Oh, cool.
what we have here is we have the data.
Oh, wow. So
So
neat.
it's really, really fun because let me take this out. Let's leave it just with that. And then we'll close with this. Let's say I select this, and now I can insert a chart. And then we can see different ways that we can visualize the data we captured.
That's really neat. Oh, wow. So cool. So cool. So cool. So possibilities going from elementary grade 2 all the way to junior high and doing real data for your math classes, right?
Correct.
Instead of just fake data like I have 52 watermelons. Like, no, I have actual data from a real microbit.
Yeah.
That's great.
And the example I was mentioning before regarding what is the I don't know what is my screen anymore. Here that I was mentioning before. I forgot my train of thought. That's okay.
That's okay. Well, we should wrap up, but that's really great going from sensors to going into the data you can actually get from those sensors and using it in a real way. So kind of took you off a little bit, but I just have these questions.
My pleasure. That's great. And I'm sure somebody is going to say, oh, I want to see more of this. And we have a workshop also
looking
on
for a
microbit and spreadsheets. Yeah.
Fantastic. Okay, thanks, Ramon. It was a great hour of microbit fun.
No, thank you so much. Always a pleasure, Darren. And I hope everybody enjoys it when you get to see it.
Fantastic. Take care.
You too.